Welcome to Dr. X Lecture Series, Data Compression. Huffman Encoding. Shannon Fano approach. This is how you do Huffman encoding using Shannon Fano, top-down approach. Let's say we want to compress the sentence, Bill beats Ben. In order to show how the Huffman encoding works, we're going to delete all the spaces between words, making it one long word, Bill beats Ben. This one long word is what we call source. Next we have to identify the alphabets in the source and each of their probability. To do that, we look into the first character, B, then we count how many B's are there in the source. In this case, it's 3. Next we make a simple note with the alphabet on top and its probability below. We then go to the next letter in the source, I, make a note below, stating I and 1. Next we have L. There's 2 L in the source, therefore make another note with L and 2. Notice the next letter after L is B. Since we've processed B before, we are going to skip this instance, and go straight to the next alphabet, which is E. Repeat this action until the end of the source. You will get the following note. The source alphabets, B, I, L, E, A, T, S, and N. And their probability of 3, 1, 2, 2, 1, 1, 1, and 1. Next we need to arrange the source according to their probability in descending order. Now we have the note like this. The source alphabets, B, L, E, I, A, T, S, and N. And their probability of 3, 2, 2, 1, 1, 1, 1, and 1. Put the source alphabet and the probability in the S and P format respectively. Now we are going to make the Huffman tree using Shannon Fano, top-down approach. In Shannon Fano approach, we need to find the middle in order to divide the alphabets according to their probability. First, we put B to the left, and the remaining sources to the right. Add up the probability on both sides. In this case, the left side has probability of 3, and the right side has probability of 9. Find the difference between total probability on the left and on the right. In this case, the absolute value of 3 minus 9 is 6. Remember the value. Next, bring the source L from the right side, and bring it to the left, together with B. Add up the probability on the left and on the right side. Calculate the difference. This time, the difference has been reduced to 2. Remember the value. Next, bring the source E from the right side, and bring it to the left, together with B and L. Add up the probability on the left and on the right side. Calculate the difference. This time, the difference remains the same, at 2. We don't need to go further to the right, because the absolute difference between the left and right side will only grow bigger from now on. Now, we have 2 ways to divide the source while having 2 as their differences between the total probability on left and the right side. Choose the one that we saw earlier between those 2. That is, B and L on the left side, and E, I, A, T, S, and N on the right side. Take the division, and draw a dotted line between them. Draw 2 branches. Bring the sources and their probabilities below in respective to their sides. Observe that the B and L branch having only 2 alphabets. Draw a dotted line in the middle, and bring the alphabets and their probability below. Notice that the alphabets have reached the tips of the branches. This means that the alphabets have become leaves. Therefore, there are nothing else to do to this side of branch. Go to the branch on the right, using the same method as before, and find the middle part to do the division with the least number of difference between the probabilities on each side. Continue the process until all of the alphabets are at the tips of branches of the tree. Now that the tree is finished, we don't need the division information in the Huffman tree. Redraw the tree leaving the branches and leaves intact. To finish up making the Huffman tree, all you need to do is to remove all the probability from the diagram. Put 0s to all left branches and 1s to all right branches. There you have it. How to make a Huffman tree using Shannon Fano approach. Thank you for watching. Don't forget to like and subscribe.